Today we are going to do lesson 3-5, and this section is called Scatter Plots and Lines of Fit. Please put your name, date, and period on your paper. We'll start with example 1. What is the relationship between the hours after sunrise, X, and the temperature, Y, shown in the scatter plot? So the relationship is that as the hours after sunrise increase, the temperature increases. We can fit a line to this data like this, and it shows a positive association or correlation. So hours increases, temperature increases. Increases. And so if they both increase, then there is a positive association. On this next one, what is the relationship between the hours after sunset and the temperature shown in the scatter plot? So as the hours after sunset increase, the temperature decreases. All right, so that's going to be a line going through most of the points. There's a correlation here where most of the dots fall on that line or around that line, but the line is going downhill, and so this is a negative association or correlation. For part C, what is the relationship between the hours after sunset and the amount of rain shown in the scatter plot? Well, there's a relationship, but it's kind of scattered. Like there's no correlation. So that's what we're going to write here. We'll just write no association or correlation. It doesn't matter how many hours after sunset. That does not seem to affect the amount of rainfall. All right, turn your page. For these try it problems, I want you to do those on your own, and I want you to do them tomorrow so that you can go back and review these notes. So don't do the try it's right now. Example 2. How can the relationship between the hours after sunrise, X, and the temperature, Y, be modeled? Well, you can sketch a line. And that shows a positive correlation. Again, for this try it, I want you to save that for tomorrow so that way you can go back and review your notes. So turn the page. Example 3. What trend line models the data in the scatter plot? We have electric hybrid cars that are sold, and in the year 2000, that's the starting year, and it seems like it's counting by twos. We have 2, 4, 6, 8, 10, 12. The first thing that we're going to do is we're going to sketch a trend line. So the trend line should be going through these points. Or not through them, but like we should have them as close to the line as we can get. So we have a few dots that are above the line and we have a few dots that are below the line, but the dots are pretty close to our trend line. The second thing we're going to do is we're going to write an equation from 2 points. And we're going to pick 2 points that are on the line. Pick 2 points on the line. And I didn't really go through any points, but we'll just kind of make up a point on the line as, use a different color so you can see. I'm going to use this point, and then I'm going to pick another point that's on a corner spot. So this point. What are those points? So this point down here is 2, comma, this is 50. And then the point up here is at 12, comma, 350. Now, if you remember from our last unit, to write an equation from 2 points, you have to find the slope. So m equals the change in y. So we're going to do the y values, 350 minus 50 over the change in x, which is 12 minus 2. That equals 300 over 10, which is equal to 3. That's a nice slope. Did I do this correctly? Oh, no. It would be not 3, it would be 30. I did my division incorrectly. Then I'm going to use point slope form just because it's easy, and then we can change it into slope intercept form if you'd like. So picking a point, I'm going to pick the first point, 2 and 50. We're going to do y minus 50 equals the slope 30 times x minus 2. So this is, I'm just going to label, this was slope, this was point slope form, and I'm going to spend some time teaching you how to use graphing calculators, not Desmos, because when you take the SAT, you have to use a TI-84 graphing calculator. You cannot use Desmos on the SATs. So I want to teach you how you could put this into a graphing calculator. And so in a graphing calculator, you have to have y by itself. So to do that, I'm just going to add 50 to both sides. And the 50's canceled, leaving us with y equals 30, parentheses x minus 2, plus 50. Now, that is fine if you're going to put it in a graphing calculator. If you wanted slope-intercept form, you could distribute and you could collect like terms, but that is not necessary unless you're trying to graph it by hand. Which if you're graphing it by hand, you would just put in the points and the slope anyway. All right, so either of those equations are correct. Point slope is fine. If you're doing your homework, they may not accept point slope form. So I guess I should distribute here just to show you what it would look like. Y equals 30 times x is 30x. 30 times negative 2 is negative 60 plus 50. I would combine the negative 60 plus 50. And that would become y equals 30x Negative 60 plus 50 is negative 10. And that is in slope-intercept form. And it's good for you to practice this algebra anyways. Slope-intercept form. All right, so that is writing the equation for the line of best fit, or it's the trend line actually. It's a trend line. And some people's trend lines may have a slightly different equation. For example, in the notes that I'm following that match these, their equation was y equals 32.1x minus 14.2. So it's slightly different than ours. But that's example 3. I want you to do the try it tomorrow on your own. All right, so turn your page. You're going to do these try it's tomorrow. Example 4. The table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So it looks like this is kind of going up. So we wanted to know when it was going to take, or how long it would take if you were downloading at an internet speed of 75 kilobytes per second. Okay, to download 100 megabytes. And remember, this is our domain, the internet speed, and that's our independent variable. It's what determines our time to download, and our time to download is our range. So in our graph over here, if you just had a piece of graph paper, you would have to label the graph to know what we're talking about. So on the bottom, our domain is our internet speed. And then we have on our range time to download. And then we have to graph the points that are in the table. And so if I have to graph the point 35, then I need to count pretty far. So maybe I want to count by tens. So this would be 10, 20. I think I'm going to have to skip count. So I'm going to skip a line 40, skip a line 60, skip a line 80, skip a line 100. I probably don't have to go above that because I only need to get up to an internet speed of 75 to show what they're asking in this question. The time to download, those are in minutes and they're decimal minutes. We're really not counting up very high. So I think I'm going to count by 0.5s. So this first line would be 0.5, then we would have 1, and then we'd have 1.5, and then we'd have 2. I'll skip the 2.5 and put 3, skip the 3.5 and put 4, skip a line 5, skip a line 6, skip a line 7. Okay, so just remember that every middle line is counting by 0.5. I am making a mess, so I'm just going to erase all these little things that I put on my graph. And now I'm going to make a scatter plot. So the first thing we're going to do to solve this problem is to make a scatter plot. Because we need the graph, just like in the first problems that we did. Make a scatter plot. So the internet speed is 35. 30 is right here. Between 30 and 40 would be 35. And if my internet speed is 35 kilobytes, then my time to download is 6.65. So a little bit above 6.5 right here. So for 40, my internet speed is 40. I'm going to go up to 5.82. That's how many minutes it's going to take to download. And then for 45 kilobytes in my internet, that's my speed. 45 is in between 40 and 50, going up to 5.17, right about here. And then I have an internet speed of 50, and that's going to take 4.65, so about here. And then for an internet speed of 55, that's going to be in between 50 and 60, 4.23, so about here. And then an internet of speed of 60, that's going to be 3.8, so right about here. The next thing I need to do is sketch a trend line. Sketch trend line. So that's the line that is going to be going through most of my points, or like close to connecting my points. And it appears to be going through some of the actual points, but I don't want to use the actual points from the table. I'm going to use points on the line. So I'm going to pick this point because it's a nice point. And I'm going to pick this point. So sort of on a corner. And I'm going to pretend that they are on corners. And we have 40, 6, and we have 60, 4. Those are fun numbers. And then we need to write its equation. So same thing, we're going to take the 2 points, we're going to find the slope. So the y values are 6 minus 4. The x values are 40 minus 60. That is going to equal, you do the math. Check my math, is that correct? And we can simplify this to -1/10, which as a decimal is just -0.1. That's our slope. The next thing that we have to do is put that into point slope form. So point slope form would be y minus, I'm going to use the top point, so y minus 6 equals -0.1, and then parentheses, x minus 40. Now I could rewrite that as I could add 6 to both sides, so y equals -0.1, x minus 40 plus 6. And if I distributed and all of that, it would end up being y equals -0.1x, and a tenth of 40. So a negative times a negative, that's going to be a positive. It's going to be +4, and 4 plus 6 is 10. So plus 10, which means that would be our y-intercept. If my graph was a little bit bigger, you could see that it would eventually have a y-intercept of +10. For the try it, I would like you to do that one tomorrow. So don't lose it because it's right here. And then we have a concept summary. So for the table, as the x values or the domain, oh, I need a pen. As the domain increases, the range also increased, and so that is a positive association. And for the next one, the domain is increasing, and the range, these numbers on the bottom, the y's, are decreasing, and so that is a negative association. And the same thing for the graphs. This is a positive correlation because the line is going uphill, and this is a negative correlation because the line is going downhill. Those are your notes for today. Tomorrow, we're going to have a catch-up day if you are in periods 2 or 5. You are going to be meeting in the auditorium tomorrow, and I want you to finish the try-its, and I would like you to work on any missing work that you have for this class. Thank you.